Welcome students to today's lecture. We will begin Module 4, Statistical Tests for 2 Samples. So up to this point we have talked about single sample tests, both the z-test and the single sample t-test. Today we're going to go a bit further and talk about the statistical test we would use if we had 2 samples. Now again, whenever we have samples, we're always interested in inferring to the population. So here we still have 2 populations, both being represented by 2 samples. So first we'll talk about when to use the paired sample t-test, and then following that we'll talk about the assumptions behind the test. As we mentioned before in class, that every statistical test has a set of assumptions that we would like to meet, and that's the same case here for the paired sample t-test. But first, let's talk about when to use a paired sample t-test. So by way of review, we've talked about 3 different types of tests up to this point. We've talked about z-scores, where we take an individual value and we compare it to a population. And that's where that population has both a mean and a standard deviation. We then talked about single sample z-tests, where we take a single sample and we compare it to a population, a known population, where again we have a mean and a standard deviation. And then last week we talked about, well, what if you don't have a standard deviation for the population? Then what do? Well, you can calculate a single sample t-test. And in a t-test we estimate the population standard deviation based on the sample. So naturally your next question should be, well, what if we don't have any population information? So in other words, we don't have a standard deviation or a mean. What would we do? Well, there's 2 things that we can do. We can do a paired sample t-test or an independent sample t-test. And we'll talk about independent sample t-test next week. But let's talk about paired sample t-tests. So we're going to do a paired sample t-test when we don't have any information in the population and we're looking to compare 2 populations to each other. So because we don't have any population information, we have to infer the means and standard deviations from samples of each of those populations. So again, we're always comparing 2 populations, and now we're going to infer the population parameters, the mean and the standard deviation, based on their respective samples. And if we can do that, then we can compare the 2 samples to each other, and if we're inferring to the populations, we're in essence comparing the 2 populations to each other. In the case for a paired sample t-test, for us to make that comparison, the samples have to be what we call dependent on each other. So we should probably talk about what dependency is and what it means, both conceptually and what we do in practice. When we say that samples are dependent on each other, what we're trying to say is that they're related in some way. In particular, the variance of one sample is related or correlated with the variance in the other sample. So dependent samples are what we call within group designs. What we mean by that is that each observation, whether it be a person or a thing, but each observation has a score in both samples. And if they have a score in both samples, then we compare those scores together for each person or each observation. So in other words, one score is dependent on the other score because it's coming from the same source. So in other words, our observations, or people, if we're measuring people, are paired with their scores. So by way of example, let's say we wanted to know if a prep course for the SAT would actually increase SAT scores. And so we may have 3 participants. We have Samantha, we may have Greg, we may have Olga, and we may just have them go into a room and we give them the SAT. So no preparation or anything, we just give them the SAT and say, here you go, let's see how well you do. And then following that measurement of the SAT, we might give them an intervention. In other words, we give them the prep course. And so they take this prep course, maybe it's a week-long prep course, and they participate in it. And then after that prep course, we give them the SAT again, most likely a different version, so they're not getting exactly the same questions, but we give them the SAT again, and we get another score, another measurement for each of them. And so this would be a within groups design. So we're measuring within the participants, or in other words, within the groups or the participants within the groups. And so that's a within groups design. So in this case, each person, Samantha, Greg, and Olga, are being measured twice. Once before a prep course and then again after a prep course. Now it's important to note here that not all within groups designs are pre-post, so before or after. Sometimes we can do within groups designs with different participants, and so that should be, you should make a note of that as well. So if I have, let's say, twins, and I want to compare them on some subject, and then maybe we want to look at the SAT, want to know how twins perform in the SAT, I can compare sets of twins because there's two of each and they're related in a particular way. In this case, from biology, because they share the same genetic code, we can compare their SAT scores to see, well, are there differences among sets of twins? So don't think that in this case that the observations have to be the same person or thing being measured twice. We can measure two different people as long as they're related in some way, what we call their dependency or dependent on each other. So we can measure a person twice and do a paired sample t-test. We can measure sets of twins and do a paired sample t-test. We could look at parents, so mother-father pairs of children. We can do a paired sample t-test because they share an environment, they share a parenting style that they both use, and so we can use a comparison there. And so within groups design doesn't always have to be the same person being measured twice. We can measure different people as long as they're correlated or paired in some way. Now, in contrast, independent samples are what we call between group designs. So in between group designs, we measure between two groups where we have different observations in each group or in each of the samples. So each observation occurs once and only once in a sample. So they're not being measured more than once, they're not being measured twice. So in this case, we say scores are independent of each other. And so there's no way we compare the scores together from one sample to another. There's no dependency or relationship between the scores. So we'll say that it's independent. And if we have an independent sample, then we have a between groups design. So by way of example, this would be a between groups design. So let's use the same example we were talking about earlier. And let's say we have two different groups here. We have Samantha, Greg, and Olga in one group where they don't receive any type of prep course. We just have them come in and we give them the SAT. And then we have Jethro, Ginger, Denise, and Jim, who we give the prep course to, and then we measure their SAT following. And so in this particular case, our samples are independent of each other. There's what we call a between groups design because we're measuring between the groups but not within the individuals. So there's no way that we can compare, let's say, Samantha's scores with Jethro's scores. They're completely two different people from different families. There's no genetic or environmental similarities or relationship that we compare together. They're completely independent individuals. And the order necessarily doesn't matter either. We can have Samantha, Greg, Olga, or Greg, Samantha, Olga. It doesn't really matter the order in either of the groups because they're completely independent of each other. So this would be a between groups design. So make sure you know the difference between a within and a between groups design and how that relates back to independent and dependent samples. So if you have a dependent sample, then you have a within groups design. If you have an independent sample, then if you have independent samples, then you have a between groups design. If you have a dependent samples and it's within group design and there's two groups, then you're doing a paired sample t-test. If you have independent samples and it's between groups design and you have two groups, then you're doing an independent samples t-test. So the last thing we need to talk about when it comes to when to conduct a paired sample t-test is the requirement of a variable that's being manipulated. So we've actually discussed this before, but we never officially identified the variable that's being manipulated in our previous modules. But we'll go ahead and do that here and officially define a variable that's being manipulated in addition to the variable that's being measured. In basic research designs, there are typically two variables that the researcher is interested in. One variable is the variable that's being manipulated. The other one is the variable that's being measured. The variable that is being manipulated is called the independent variable. The variable that is being measured is called the dependent variable. So the independent variable is the one we're talking about right now, the variable that's being manipulated. And so if we look at our example of the prep course and SAT, the levels of the prep course would be our independent variable. The SAT scores would be our dependent variable. That's what's being measured. So the researcher has some level of control over the independent variable. In other words, the levels of the prep course. The researcher may control who receives the prep course and who doesn't. Or in a within groups, dependent groups design for, let's say, a paired sample t-test, the researcher may control when the participants receive a particular treatment. So in this case, not so much who receives the prep course, but when they receive it. So in a paired sample t-test and a within groups designs, a dependent samples design, we have one sample that's being measured twice, so every observation is being measured twice, and so the researcher controls when they receive the prep course. So at time 1, no prep course, we just measure the SAT, we give some intervention, and then we measure a second time with the prep course, and so the researcher in this case has manipulated when the participants receive that prep course. Alright, so an independent variable, you have at least 2 groups. Now if you're doing a t-test, you'll only have 2 groups or 2 samples. But in other designs you may have more than 2 groups, but there's always at least 2. So one condition or one group, one level or one sample. So just note that condition, group, level, and sample are telling us the same thing. But in one condition we'll have what's called the control. So this is the absence of an intervention or absence of treatment. So this would be the no prep course condition, or the no prep course sample, or the no prep course group, or the no prep course level. So we can say any of those terms is telling us the same thing. And then we have a second condition or a second group or level that's called the experimental group or the experimental level. The experimental level receives the treatment, in this case the prep course. So in this particular example we have one condition of no prep course, and then we give an intervention, and then we measure them again, and then we have an experimental group that has received the prep course, and we then make a comparison between the no prep course versus the prep course. Now it should be noted here also that don't mix up independent and dependent variables with independent and dependent groups or group designs. Those are 2 different things, and so separate those out. Sometimes I see students confuse the 2. So if we have dependent groups, do we have a within groups design, or dependent samples within groups designs? Independent groups, independent samples, we have between groups designs. That's different than independent and dependent variable. So make sure you separate those terms from each other. Now the variable that we measure is the dependent variable, and so this would be in our example of scores on the SAT. So the scores on the SAT depend on whether or not the participants have received the prep course. And so they depend on the independent variable. They depend on the variable that's being manipulated by the researcher. So in this case we're going to get scores on SAT in both conditions, with and without the prep course, but the scores of the SAT should depend on whether or not the students received the prep course or did not receive the prep course. Those with the prep course should have higher SATs if the prep course is effective. If they don't receive the prep course, then the SAT score should be lower, again assuming that the prep course is effective. So in our particular example here we have prep course effectiveness on SAT scores, and so we have 2 variables. We have the levels of the prep course, that's our independent variable. Then we have the scores on the SAT, and that's the dependent variable. So my question for you is, what type of variable is the independent variable, and what type of variable is the dependent variable? So again, are the variables nominal, ordinal, interval, or ratio? So take a moment, pause the video, and just write down in your notes really quick what type of variable is the independent variable and what type of variable is the dependent variable. Okay, so let's check, see what you wrote down. So the levels of the prep course is the independent variable. In this case that is a nominal variable. It's a categorical variable. Our participants either received the prep course or they did not receive the prep course. And so maybe we code those who received the prep course as a 1 and those who did not receive the prep course as a 0. So we give them those numbers as categories. Regardless, that's a nominal variable. It's a discrete variable. The dependent variable in this particular case, the SAT score, is likely an interval variable. So a 0 on the SAT doesn't mean you don't have any particular aptitude when it comes to testing of standardized works. It's just saying that you scored really, really low. But it's not the absolute absence of aptitude. So in this case it's probably best an interval variable. So the independent variable will typically be nominal. And then the dependent variable will typically be a scale variable, whether interval or ratio. So keep that in mind as you're answering those types of questions on assignments and also on the exam, that your independent variable in this case is likely, if we have groups, is likely to be nominal. We're going to divide them up into 2 different categories, and the dependent variable is likely to be continuous, an interval or a ratio variable.